Hi guys, today we're going to learn about question number 6 from the AP Calculus BC free response. So the function f has derivatives of all orders for all real numbers. It is known that f of 0 is equal to 2, f prime of 0 is equal to 3, and f double prime of x is equal to negative f of x squared, and then what we know is that f triple prime of x is equal to negative 2x times f prime of x squared. So they ask you to find the fourth derivative evaluated at x. Then they want you to write the fourth-degree Taylor polynomial for f about x equals 0. We need to show all the work that leads to your answer. Okay, so let's start with the fourth derivative. We know that the fourth derivative evaluated at x is going to be equal to the derivative of this guy. So what are you going to do? These two are multiplying each other, so this is screaming a product rule. Okay, so you're going to take the first one times the derivative of the second one. Here you need to be very careful because you have there a chain rule. Okay, after that plus then the second one, which is this guy, times the derivative of the first one, which you know that is going to be negative 2. So you have this equation. Okay, of course we can simplify this. So you know that it's going to be negative 4x squared, and then you have the double prime x squared, okay, and then plus, well, we can put the negative 2 here since I already got that, but you can change that for a negative, okay. So we have that situation, okay. Then they want you to write the fourth-degree Taylor polynomial. Fourth-degree Taylor polynomial, what you need is you need f of 0, okay, which you do have because it's 2. We need f prime of 0, which you do have because they tell you that it's 3. You need the double prime of 0, which we can get because you can plug the 0. So you have that it's negative f of 0 squared, which you know that this is going to be negative 2. Okay? In addition to that, what do you need here? What we need is the third derivative, which we can plug in the hypothesis of the problem in this one that we have over here. Okay, so what you're going to do there, you have that it's going to be negative times 0. Okay, so you know that that one goes away because that's a 0. Okay, and then the fourth derivative, okay, which we got, that's what we needed. Okay, so we have it over here. Okay, so you know that it's going to be negative 4 times 0, so all that term is going to fly to 0. Okay, negative 2, and then you have f prime of 0. Okay, so you know that this is going to be negative 2 times 3, which is going to be negative 6. So pretty neat. Over here we have, let's call it polynomial degree 4 of x is going to be equal to 2, and then you have plus 3x minus 2x squared divided by 2 factorial. Then you have that it's going to be plus 0x cubed divided by 3 factorial. And last but not least, you have the 6x power 4 divided by 4 factorial. Over here, you pretty much can leave it like that, as you know, or you can simplify and you have that this beautiful thing is going to be 2 plus 3x minus x squared. That's a 0, and then you have that one simplifies as 1 over 4 times x, and that's going to be your polynomial degree 4, and then you are done for part A of question number 6. For part B, what we have is that the fourth-degree Taylor polynomial for f about x equals 0 is used to approximate f of 0.1. Given that the absolute value of the fifth derivative evaluated at x is less or equal than 15 for x that it's between 0 and 0.5, they tell you to use the Lagrange error bound to show that this approximation is within 1 over 10 to the power of 5 of the exact value of f of 0.1. So over here it's a pretty straightforward question which you need to follow the instructions. So you need to use the Lagrange error bound. So you can use different notation here. Okay, so you can use the error. Okay, instead of error, you might want to use something that looks like this, right? You might want to use this guy, right? Moreover, you can use also, let's say that you want to be more specific. You want to use on the polynomial, we call it p sub 4. So we can use all of this, right? Any of this. You know that those are going to be equal to the fifth derivative of this z, that z is between your z and c and x, okay, of 0.1 to the power of 5 divided by 5 factorial. You know that this is going to have an absolute value, and since you know you have that this is a number, but we do have that this is bounded from the hypothesis of the problem, so we know that this is less than, okay, here we are going to be using the fact that they are giving you this bound for specifically the x that it's between 0 and 0.5, which you know that it's true, so you are going to use directly what they give you over there. So you are going to plug, instead of this, the 15, then the 0.1 to the power of 5 divided by 5 factorial. Over here, please note that I didn't put the absolute value because we already know that this value is positive, right? So from here, you know that this is going to be less than 1 over 10 to the power of 5, then you are done, and this is happening by Lagrange error bound. Wasn't that simple? So the only thing that you need to remember is that you need to use this from the hypothesis of the problem, and pretty much is following the Lagrange error bound formula. For part C, what we have is that a function g such that g of 0 is equal to 4, and we have that g prime of x is equal to e to the power of x times f of x. They want you to write the second degree Taylor polynomial for g about x equals 0. So what are you going to do here? Here, what you have is they want you to write the second degree Taylor polynomial. So what we need is we need g of 0, g prime of 0, and g double prime of 0. Okay, that's what we need. So let's see what we have. I do have that this guy is 4. Then they give you that this guy, pretty much you can plug the 0. Okay, so you have something like this. Okay, so from here, the hypothesis of the problem, let me bring it here. You know that f of 0 is 2. So you have that this is going to be 2. Okay, so now the business is how in the world we're going to get this one. So pretty similar to part A, what you are going to do here is you are going to take your g prime, and since we need double prime, you know that I can take the derivative of this guy. Again, you see that it's two functions multiplying each other, so you are going to use the beautiful product rule. Okay, so g double prime of x is going to be equal to e power x times f prime of x plus f of x times the derivative of e to the x, which you know that it's itself. Okay, so when we evaluate this at 0, you have that it's e to the power of 0 f prime of 0 plus f of 0 times e to the power of 0. So what you have here is that f prime of 0, we know from the hypothesis of the problem, let me bring it here, we know that that one is going to be 3. Okay, and this guy is going to be 2, so I know how to add, and I'm going to use my 5 there. Okay, so I have pretty much all the pieces of the puzzle. Now I need to put here the puzzle together. So I have the polynomial degree 2 in this case of x is going to be equal to what? This polynomial is going to be 4 plus 2x plus 5x squared divided by 2 factorial. We can simplify this one by just erasing the factorial, right? And it's as correct. And that's pretty much for question number 6 of your AP test. I hope that you have it correct. And I hope that you find this video helpful. Bye!